Welcome friends. In this animation, we consider a square conducting loop of side A, moving at a constant velocity v perpendicular to a uniform and static magnetic field B directed into the page. The magnetic field spans a region of width W, which is greater than the loop's size. The loop begins to enter the field at time t equals 0, then travels completely through, and finally exits the magnetic region. We will calculate the induced EMF as a function of time, explore the direction of the induced current using Lenz's law, and understand how energy is conserved in the process. A square conducting loop of side A moves with constant velocity v into a region where a uniform and static magnetic field B is directed into the page. As the loop enters the magnetic field, the flux through it increases. By Lenz's law and right-hand rule, a counterclockwise current is induced, which produces a magnetic field in opposite direction of applied field B that opposes the cause of induced EMF. Here, the induced EMF is negative BAV. Once the loop is completely inside, the magnetic flux remains constant. Hence, the flux through it is not changed, and no EMF is induced. As the loop exits the magnetic field, the flux through it decreases. According to the Lenz law and right-hand rule, a clockwise current is induced that produces a magnetic field in the direction of applied field B and resist the cause of induced EMF. The EMF is now positive BAV. This is how the EMF changes with time. During the entry phase, the EMF is negative. This is shown by the first dip in the graph. While the loop is fully inside the magnetic field, the EMF is 0. This flat section represents that period. As the loop exits, the EMF becomes positive, which corresponds to this rise at the end of the graph. In summary, EMF is induced due to changing magnetic flux. Lenz's law dictates the current direction. Motion through the field provides the energy that produces the induced EMF. This induced EMF generates a current in the loop, resulting in energy dissipation as Joule heating. Thank you for watching the video.